It is Decades Day, and I can see all y'all wearing your favorite decades, or not. Did anybody actually dress up for today? No. What'd you say? Tomorrow's Jersey Day. Today is Decades Day. All right, well anyways, on the warm-up. Now, y'all remember when we did this before? Distance formula? Yeah? We're going to be using that today for classifying triangles. So let me show you what I mean first. Let's do this warm-up. Distance equals, and then long square root sign. You always need to write what you're going to type in your calculator, right? So what is x2? What's the second x value? 5. So parentheses 5 minus, what's x1? -1. So you can put 5 minus -1 or 5 plus 1, right? Minus a negative gives you a plus sign. Okay. Then we put the squared plus y2, -7, and then minus what? 3. Parentheses squared. Okay, so if you got that, then you can plug it in, get your answer. So let's do that. Okay, 5 minus -1. And then -7 minus 3. 11.66. All right, so y'all are able to type it in to get your distance. So make sure you have that written down. And I'm going to pass out your note sheet. True. I got distracted. I know you didn't. All right, next one. Here we go. On your notes, at the very top, go ahead and write this formula down, which you hopefully know, but either way, now you can have it on your notes again from the warm-up. So make sure you're writing this down. Distance equals the square root of parentheses x2 minus x1 parentheses squared plus parentheses y2 minus y1 parentheses squared. You're a fox. And you can plot those 3 points. So 1, 2, put a point there. A. B is -4, 8, put a point there. And -5, -6. And then use that straight edge of your protractor that you grabbed on the way in. Here, pass. And make straight lines, please. Now, for classifying, we've done this the last couple of days. Classifying is when you tell me, is it acute, obtuse, right? Is it scalene, equilateral, isosceles? The best way to know that is when you have plotted points is you need to use your distance formula. Okay? I don't know off the top of my head if these sides are the same. They look like they could be. They're kind of close together. But distance formula will tell us for sure. So, for all three sides, we're going to use distance formula so we can classify it. So let's start with AB. Okay, so I'm going to put a long square root. And AB, I'm going to subtract x2 minus x1. So use the B value for x2 and the A value for x1. So negative 4 minus 1 parentheses squared plus 8 minus 2 squared. Okay. So make sure you plot those points and write that part down. Then we're going to plug it into the calculator. So I'll leave this over here. Okay, so plugging this in, square root of parentheses, negative 4 minus 1 squared plus 8 minus 2 squared. Gives me 7.81. Okay. My remote is not working. Okay, there we go. So, 8, what was it again? 7.81, sorry. Cool. Now, let's do BC. Now I'm only going to look at B and C for my points, right? So, x2 minus x1. So, long square root, negative 5 minus negative 4 squared. I'm subtracting a negative number. You can put a plus sign if you want. Write this down. Plus negative 6 minus 8. Don't forget the squared. Okay. So once again, let's go to the calculator. Square root, parentheses, negative 5 minus negative 4 parentheses squared plus negative 6 minus 8 squared, 14.04. Okay. Right, so if you have a minus negative, you could write it as a plus instead. That's fine. Either way. Okay. So we had 14.04. Okay, and last but not least, AC. Now you're kind of use the A and the C point, like forget the B. So x2 minus x1, got a long square root, and we're doing negative 5 minus 1, parentheses squared, plus y2 minus y1, negative 6 minus 2, parentheses squared. And again, we're going to take that to the calculator. There we go. And then we type it in. Negative 5 minus 1 squared plus negative 6 minus 2 squared gives us 10. Okay? So there we go. Now, by doing this, you'll get the hang of it fairly quickly. Notice the bottom part. You're not done until you actually do what it says. Classify it. So we need to classify it two ways, by the sides and the angles. So look at these three sides. If all three sides are different numbers, what do you call that? Scalene. Miss Moreau's not here to sing her song, but it's scalene, right? You want me to do it? Scalene. Scalene, scalene, scalene. All right, next one. Angles. Now, Do you think this is acute, obtuse, or right? This looks acute. But what is that? What is angle A?
Wait, that might be right. I can't tell.
If only there was a way to tell how many degrees it is. Oh, there is. May I? All right, so I'm going to show you how to do this. If you're not sure, you got the means, you got the tool to measure this. Now, once this, there you go. So here's how, if I'm trying to measure this, and by the way, I want to make nice straight lines. All right. Now, I'm going a little further here because when I line this up, I want to see the degrees, right? Now, check it out. This has to start at 0, and then it goes up, 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 past 90. It's about 96, 97, maybe 98. Okay? So does everyone see that if you measure it, this is actually bigger than 90? It might kind of look 90, but it's close, and it's not exactly. Okay? So, thank you. We're going to put obtuse, right? Yes. Obtuse. Cool. Not isosceles. Scalene, because all the sides are different. Right? All right, let's do the second one. Ready? Plot those points down there on number 2. Anyone still need this? Okay, and number 2, let's plot these points. 3, 6. -1, 3. And then 2, 7. Little piece of pizza right there. Okay? Plot those points. True. Okay, now let's do, again, distance formula. So DE, so -1 minus 3 squared plus 3 minus 6 squared plug it in, square root, -1 minus 3 plus 3 minus 6 is legit 5. Look at that. So 5 is my DE. By the way, this should be DEF. Okay, let's try EF. So x2 minus x1 is 2 minus -1 squared plus y2 minus y1, 7 minus 3 squared. Let's type that in. Square root 2 minus -1. What? Oh, thank you. Appreciate it. 2 minus -1 plus 7 minus 3 squared. And I get 5 again. What? All right, and then DF is, we're going to use 2 and 3, so big square root, 2 minus 3 squared plus 7 minus 6 squared. And again, you're always showing your work by writing down what you're going to type in, yeah? So, to the calculator, square root 2 minus 3, 7 minus 6, 1.41. Okay, so what kind of triangle is this when it has two sides that are the same? What? Sure can. These are congruent. DE and EF. Isosceles. And what about the angles? What do you think? Okay, they are acute. They're less than 90. Angle F and angle D look like they might be close to 90, but they can't both be 90. Wouldn't make a triangle, okay? So that's isosceles and acute. You can always measure if you're unsure. All right? The main thing I do need to see is what are you typing in, and then classify. Cool? All right, I'm going to pass out the assignment. We're going to listen to those 90s jams, remembering those 3 Super Bowls.